National Electrical Code Section 700.10 requires the housing of an emergency generator to be designed and constructed so as not to present a fire hazard. National Electrical Code Section 680.20 refers to Chapters 2, 3, and 5 for the requirements that apply. Chapter 2 does not contain any requirements for generators. Chapter 3 contains general wiring methods and materials requirements. Chapter 5 contains wiring methods and materials requirements for special occupancies. National Electrical Code Sections 500.3b through d contain specific requirements for generators in hazardous, which is to say, classified locations. Based on the information provided, the requirements of National Electrical Code Sections 700.10 are met by either a dedicated building or a vendor enclosure, such as a flexi-van. Selection of which method to use should be based on the specific hazards present at the facility and which method provides the best protection from those hazards. Therefore, either a dedicated building or a vendor enclosure could be adequate, depending on the specific circumstances. To elaborate on the code sections mentioned, let's consider each in more detail. First, National Electrical Code Section 700.10, which addresses emergency systems and their wiring, requires that the emergency generator housing be designed and constructed to prevent fire hazards. This implies considerations such as using fire-resistant materials, ensuring adequate ventilation to prevent overheating, and providing appropriate fire suppression systems. The goal is to minimize the risk of a fire originating within the generator housing or spreading to surrounding areas. Now, National Electrical Code Section 680.20 directs us to Chapters 2, 3, and 5 for further applicable requirements. Chapter 2 generally covers wiring and protection, but it does not contain specific requirements tailored to generators. Therefore, its relevance to the question is limited. Chapter 3, on the other hand, addresses general wiring methods and materials. This chapter outlines requirements for conductors, cables, raceways, and other components used in electrical installations. These requirements aim to ensure the safe and reliable operation of electrical systems and to minimize the risk of electrical shock or fire. Chapter 5 is crucial, as it covers wiring methods and materials for special occupancies. Special occupancies refer to locations with unique hazards or characteristics that require specific electrical installation practices. This could include hazardous locations, healthcare facilities, and other environments where the risk of electrical hazards is elevated. Within Chapter 5, National Electrical Code Sections 500.3b through d provide specific requirements for generators installed in hazardous, that is, classified locations. Hazardous locations are areas where flammable gases, vapors, or dust may be present in sufficient quantities to create a risk of explosion or fire. These locations are classified based on the type and likelihood of the hazard, and specific electrical equipment and wiring methods are required to minimize the risk of ignition. Considering the points above, the choice between a dedicated building and a vendor enclosure depends on a thorough assessment of the specific hazards present at the gas plant facility. This assessment should consider factors such as the presence of flammable substances, the potential for spills or leaks, and the likelihood of exposure to corrosive agents. Once the hazards have been identified, the appropriate protection methods can be determined. A dedicated building offers several advantages in terms of protection. It can be designed and constructed to provide a robust barrier against fire, explosion, and other hazards. It can also be equipped with specialized ventilation, fire suppression, and monitoring systems to enhance safety. However, a dedicated building may be more expensive and require more space than a vendor enclosure. Vendor enclosures, also known as flexi-vans, are prefabricated structures designed to house generators and other equipment. They offer a cost-effective and flexible solution for protecting generators from the elements and minimizing noise pollution. However, vendor enclosures may not provide the same level of protection as a dedicated building, particularly in hazardous locations. To ensure compliance with the National Electrical Code and to provide adequate protection for the emergency generator, the selection of housing method should be based on a careful evaluation of the specific hazards present at the gas plant facility. The chosen method should provide adequate protection against fire, explosion, electrical shock, and other hazards, and it should be installed and maintained in accordance with all applicable codes and standards. In summary, the National Electrical Code provides a framework for ensuring the safe installation and operation of emergency generators in gas plants and other facilities. By carefully considering the specific hazards present at the facility and selecting the appropriate housing method, it is possible to provide adequate protection for the generator and to minimize the risk of accidents. Remember to consult with qualified electrical engineers and other professionals to ensure that the installation meets all applicable requirements. To further clarify the requirements, let us delve into specific aspects of generator installations in hazardous locations, as these often apply to gas plants. National Electrical Code Article 500 addresses hazardous classified locations, defining them as areas where fire or explosion hazards may exist due to flammable gases, vapors, liquids, combustible dust, or ignitable fibers or flyings. The classification system divides these locations into classes, divisions, and zones, each with specific requirements for electrical equipment and wiring. For instance, Class 1 locations involve flammable gases or vapors, Class 2 involve combustible dust, and Class 3 involve ignitable fibers or flyings. Divisions indicate the likelihood of the hazardous material being present under normal or abnormal conditions, with Division 1 indicating a higher likelihood than Division 2. Zones, used in an alternative classification system, also indicate the probability of a hazardous atmosphere being present. Generators installed in Class 1, Division 1 or Zone 1 locations require explosion-proof enclosures or intrinsically safe systems to prevent ignition of the flammable atmosphere. Explosion-proof enclosures are designed to contain an internal explosion and prevent propagation to the surrounding environment. Intrinsically safe systems limit the energy available in electrical circuits to levels below that require to ignite the hazardous material. In Class 1, Division 2 or Zone 2 locations, equipment must be designed to prevent ignition during abnormal conditions, such as equipment failure. This can be achieved through methods like purged and pressurized enclosures, non-incentive equipment, or encapsulation. Class 2 locations require equipment to be dust ignition proof or designed to prevent surface temperatures from exceeding the ignition temperature of the specific dust present. Dust ignition proof enclosures prevent the ingress of dust and minimize the risk of ignition due to arcing or hot surfaces. Class 3 locations require equipment to minimize the accumulation of fibers or flyings and prevent them from coming into contact with hot surfaces or electrical arcs. In addition to the classification of the location, other factors can influence the choice of generator housing and installation methods. Ventilation is crucial to prevent the accumulation of hazardous gases or vapors within the generator enclosure. Proper ventilation can dilute the concentration of flammable materials and reduce the risk of explosion or fire. Fire suppression systems are essential to quickly extinguish a fire in the event of an ignition. These systems can include automatic sprinklers, foam systems, or dry chemical systems, depending on the specific hazards present. Monitoring systems can provide early warning of abnormal conditions, such as gas leaks, high temperatures, or equipment malfunctions. These systems can trigger alarms and automatically shut down the generator to prevent accident. Grounding and bonding are critical to minimize the risk of electrical shock and prevent the accumulation of static electricity, which can be an ignition source in hazardous locations. Proper grounding and bonding ensure that electrical faults are quickly cleared and that static charges are safely dissipated. Regular inspection and maintenance are essential to ensure the continued safe operation of the generator and its housing. Inspections should include checking for leaks, corrosion, damaged wiring, and other potential hazards. Maintenance should include lubricating moving parts, replacing worn components, and testing safety systems. Furthermore, compliance with other applicable codes and standards is necessary. This may include local building codes, fire codes, and environmental regulations. It is important to consult with local authorities and experts to ensure that the installation meets all applicable requirements. When considering vendor enclosures, it is important to ensure that they are designed and constructed to meet the specific requirements for the hazardous location. The enclosure should be made of appropriate materials, such as steel or aluminum, and it should be properly sealed to prevent the ingress of hazardous materials. The enclosure should also be equipped with appropriate ventilation, fire suppression, and monitoring systems. In summary, the selection of generator housing and installation methods for gas plants requires a comprehensive assessment of the specific hazards present at the facility. The chosen method should comply with all applicable codes and standards and provide adequate protection against fire, explosion, electrical shock, and other hazards. It is important to consult with qualified professionals to ensure that the installation is safe and reliable. The NEC provides a good starting point, but specific engineering judgment and local regulations should always be considered. The primary goal is always safety and prevention of hazards.